Maths live stream, and today we are going to continue with what we started last time, which was number systems. So just to be sure, let's quickly revise what we did last time, and then we will enter into exponent form and the index form. So let me first share my screen with you. Okay, so this is my screen. So last time we learned rounding off to nearest tens, hundreds, and thousands, if I'm not wrong. Yes, we did that. And then we did estimation. We also did operations. That means the BODMAS rule. So if you have missed that streaming, you can go to our channel, or I will post the link for that last stream below this video after we are done. Okay, so today we are going to start with something called as index form or exponent form or and exponent form. Hello. What does it mean? Like if we write 2 times 2, it's very easy to write, right? We can write 2 times 2, 2 times 2 times 2, or 2 times 3 times 3 times 3 times 3. But how many times are we going to keep on writing the same number again and again and again and again? So that's a problem. So what we do is we write it in something called as an index form. Okay? What index form means is we count how many numbers are there. So we have, let's say this one, we have 3 2s. So I will write a 2, and on top of that I will write a little 3. So now this is called index form of 2 into 2 into 2. Now this one is called the base number or the base. See, this thing is very important right now because we are going to do index form and exponent form in algebra also. So as long as we are very good with this, with numbers, it's very easy to implement when we go to the algebra. So slowly as we go ahead, all the rules that I'm teaching you now for numbers are going to be applicable in algebra and geometry too. So you pay very good attention to each and every detail. Okay. So now going forward, 2 is the base number, 3 is the index or the exponent or power. What it literally means is 2 is multiplied to itself 3 times. So till 2 raised to 2, 2 raised to 3, we have different names for that. So anything raised to 2 is called 2 squared. Okay, so anything 7 raised to 2 is 7 squared, 4 raised to 2 is 4 squared. So it is 2 into 2 basically, or 7 into 7, or 4 into 4. Now 2 raised to 3 is called 2 cubed. So it's 7 raised to 3 is 7 cubed, 4 raised to 3 is 4 cubed. So it's 7 into 7 into 7, or 4 into 4 into 4. So these only powers of 2 and 3 have a specific name of squared and cube, which you will be using after this. But let's say you have something like 6 raised to 5. Okay, 6 and there is a little 5 on top of it. You say it as 6 raised to 5 or 6 power 5. Both are same, both mean that 6 is multiplied to itself 5 times. Okay. Practically speaking, there is nothing much to it. This is the only thing. But this is very useful when we have very large numbers factored and then we need to write those factors properly so that they are readable. So one of the reasons, and then of course we have a lot of applications of this in algebra. So I'll do one thing, I will make it smaller and you people can copy it, and then we will move ahead and we will go and see how we can represent the string of given numbers in powers. Okay. So I suppose you have written this down, and then we will go to, so let's say I have a long string of numbers, okay? Says that 2 times 2 times 2 times 3 times 3 times 3 times 3 times 5 times 5. It's such a big number to read. So what I will write it, it's 2 cube because there are 3 2's multiplied by 3 raised to 4 because there are 4 3's multiplied to each other multiplied by 5 square. Now we have to remember that when they are in this form, you cannot multiply these two together because there are 2 into 3. You cannot make it as 6 raised to 12. No, it's not like that. If they have same powers, you can combine them. But generally, when we are writing factors or any large string of numbers in this form, we keep the numbers in prime number form. So let's say if someone gives you this 4 times 4 times 6 times 6 times 7 times 7, you so you will naturally write is at 4 raised to 2 into 6 raised to 2 into 7 raised to 2. But we generally factorize it into our prime numbers. So it is 2 times 2 for this 4 times 2 times 2 for this 4 times 2 times 3 for this 6 times 2 times 3 for this 6, and then we have 7 times 7. So we count how many 2's are there. 1, 2, 3, 4, 5 and 6. So we write 2 raised to 6 multiplied by how many 3's do we have? 1 and 2. So 3 raised to 2 multiplied by 7 raised to 2. So this same number we have represented in this form. So generally when you write factors in this form, and many IGCSE papers have this kind of question, when you go to 10th grade and you appear for your IGCSE exam, they give you a very big number, they ask you to factorize and they ask you to put the number in this particular fashion. So it's better if you practice this and get this very nicely in your head, because this is going to make your life very easy as we go ahead. Okay, now these rules are definitely going to apply as in algebra, as I have said before. They may apply in geometry wherever necessary. I am not saying that they will always apply in geometry, for at least for exponents, but they may apply for making taking a cube or volume or area, calculating that we may have to use our index forms over there. But in algebra, definitely, as we go ahead, we will do index form in algebra too once we start doing algebra. So this one is first, it's useful in forming writing factors, and second, it is going to be very useful in algebra. So what we are going to do is we are going to practice these numbers. Okay, we are going to see how to write numbers in index form. So what I'm going to do is I'm going to give you a few questions. So I will write the question as represent in index form. Okay. First one. So these are the numbers that we have to write in index form. So I will give you about 5 minutes to do this in index form, and then we will solve it, or I will solve it for you. Okay. Okay, you have 1 more minute, and then I will tell you the answer for this. Okay. Okay, fine. So now we count. We know we have 1, 2, 3, and 4 and 5 different types of prime numbers here. So we have a 2, and we have three twos. So we are going to write 2 raised to 3. Then we have three threes. So we are again going to write 3 raised to 3. Then we have two fives. So raised to 2, 7 and 11. So 2 cube into 3 cube into 5 square into 7 into 11 is how this number is represented. For this one, now all the numbers are jumbled up over here. So we know that we have three different types of numbers here. So we'll just write 2 here, multiplied by 3, multiplied by 5. Now we'll first count how many 2's do we have. 1, 2 and 3. So we have a 2 cube. Then we have two threes, so 3 square, 1, 2, 3, 4, 5 raised to 4. So let's count again. We have 1, 5, 2, 5, 3, 5 and 4 fives. So it's 5 raised to 4. Then we have 1, 2, 2 twos, 3 twos. So we have 2 raised to 3, and we have a 3 and a 3. So 3 raised to 2. Now the tricky one is this one, the third one, where we have to actually factorize all the numbers to get their prime numbers. So let's start with 6. So it's 2 into 3. 12 is 2 into 2 into 3. Then 3 is 9 into 9 is 3 into 3. Then 56 is 8 into 7, where 8 is 2 into 2 into 2. So 2 into 2 into 2 into 7 into 30. So how many different types of numbers do we have? We have 4 different numbers. So we have a 2, we have a 3, we have a 7, and we have a 13. So we are first going to count 2's. 1, 2, 3, 4, 5 and 6. So it's 2 to the power 6, or 2 raised to 6. Then we have 1, 2, 3, 4. 4 threes. So we are going to write 3 to the power 4, and then 1 7 and 1 13. So this whole series of numbers can be represented in this form. Okay. Now it can be written as represent in this form or represent in that form. So we are going to do that next. So let's say we have a number 1000. Okay, and they want us in powers of 10. Okay, so 1000 is what? 100 into 10. That is equal to 10 into 10 into 10. So how many tens are there? 3 tens are there. So here we can write 10 raised to 3. So basically we factorize it with 10. Even though it is not a prime factor, 10 raised to something or 10 powered something is a very, very important number when it comes to something called as scientific form, which you will be learning in, I think, in next year. Yes, scientific form is generally introduced in grade 8. So the scientific form helps us to write very huge numbers in a very concise and small number, or very, very small numbers in a very readable format. Okay, we'll get into the detail whenever it will come, but you have to remember that even though it is not a prime factorization over here, 10 raised to something has a very, very important role when it comes to your mathematics. So writing 10 raised to something is completely fine as if they have specified it. So let's say I have 10,000. So I have one 10, then I have another 10, then I have another 10, then I have another 10. So it is 10 raised to 4. Now if you see how many zeros are there, that is the power 10 is raised to. So here there are 3 zeros, so 10 is raised to 3. Now here there are 4 zeros, 10 is raised to 4. So when it comes to numbers which are divisible by 10 or which are powers of 10, this helps you to just count the number of zeros and write it. So let's say I have 1 2 3 4 5. It is 10 raised to 5. You really don't need to factorize it, so it's just 10 raised to 5. Okay, so how about I'll keep this as it is, and you help me write down an index form. 1 million. 1 2. I'm not going to read how many tens are there, what zeros are there. So how much is this? Yes, it is 10 raised to 6. So it is 1 million basically. So now when you go to scientific form and they say 2 million, you can write it as 2 into 10 raised to 6. Okay. Okay. So now let's see how to factorize a number. And okay. Uh, So I have a very huge number here, which is 10800. Um, those who have done CBSE or CLSP before, they know that there are few divisibility rules that we can use to factorize this. So since we are on the topic, we will go on revising the divisibility rules. So first divisibility rule is divisibility by 2. So this rule states that any number that ends with a 2, 4, 8, 6 or 0 is divisible by 2. If you want, you can write this down because these rules are really going to be very helpful as you go ahead, because your calculator will not factorize this for you. Even if you are using calculator, you'll have to factorize it yourself using these divisibility rules. So what does it say? The divisibility rule of 2 says that if a number ends with a 2, 4, 8, 6 or 0, the number is divisible by 2. So you can always, if your given number is ending with these 5 digits, you can always start dividing by 2. It, it will make the number smaller, so you can go on adding that. Next one is divisibility by 3. It says that if the addition of all the digits is divisible by 3. So if let's say I have 126. Okay, so 1 plus 2 plus 6 is equal to 9. Now 9 is divisible by 3, so 126 is divisible by 3. So what does the divisibility rule by 3 state? It states that if all the digits in a number add up to a number divisible by 3, then the original number is divisible by 3. Okay, so you can write this down as well. Next one is divisibility by 4. It states that if the last two digits of any number are divisible by 4, your number is divisible by 4. Yeah. So let's say I have 284. Now I know that 84 is divisible by 4, so you can try dividing 284 by 4. So let's say 7 times 28, 0, 4 comes down, 1, 0. So it is divisible by 4. If you want, we can try another number. Let's say 556. Since it is 4, it has to be an even number. So 1 times 4 is 4. 1 carry, 5 comes down. 4 times 3 is 12. So we get 3 and the 6 comes down. And then 4 times 9 is 36. 0. So 556 is also divisible by 139 because 56 itself is divisible by 4. Okay, so 556 is divisible by 4 because 56 itself is divisible by 4. So what does the divisibility rule of 4 state? It states that if the last two digits of a number are divisible by 4, then the entire number is divisible by 4. Next one is, this is the easiest rule, divisibility rule of 5. So any number that ends with a 5 or a 0 is divisible by 5. As plain as that. We all know that 5's table is 5, 10, 15, 20, 25, 30, 35. So all of them are alternately ending with 5 and 0, 5 and 0, 5 and 0. So any number that ends with a 5 or a 0 is divisible by 5. Next one is divisibility rule of 6. This rule states that if any number is divisible by 2 and 3, not or, and, so number has to be divisible by both the numbers, then it is divisible by 6. So for example, let's take a number like 696. Okay, so 696, is it an even number? Yes, so it is divisible by 2. Is it divisible by 3? 6 plus 9 is 15 plus 6 is 21. So yes, it is divisible by 3. So it definitely has to be divisible by 6. But I'm going to show you what I mean by that. So times 1, 6 goes here. 0, 9 comes here. Again times 1, 6 goes here. 3 comes down. And then we have a 6 that comes down. So it's 6. So 36. 0. So this number is divisible by 6 because it is divisible by 2 and it is divisible by 3. Okay, so this rule is very important to remember, that there is a and here. So it has to have both the numbers 2 and 3. It's just not that it is only 2 or only 3. It has to have both the numbers 2 and 3. Then it is definitely divisible by 6. Of course, 2 into 3 is 6. So it has to be divisible by 6. Now we will skip divisibility rule of 7 because it is not that simple to understand and it is not in the course here. Maybe someday we will do a session where We will do some things which are not in the syllabus but quite interesting. Then we will cover divisibility rule of 7. So divisible by 8. Now you will think that okay, if 6 is divisible by, rule of 6 is divisible by 2 and 3, rule of 8 will be divisible by 4, 2 and 4. That's not right. Divisibility rule of 8 says that last 3 digits of a number should be divisible by 8. Okay, so the divisibility by 2 and 4 doesn't apply here, not same like 6. Best example is 28. 28 is divisible by 2, 28 is divisible by 4, but it is not divisible by 8. So I rest my case there. Next one is divisible by 9. So for divisibility by 9, all the digits of a number should add up to 9. That's the only rule. All digits add up to 9. Okay, so let's say I have a number 342. What will I do? I will see if 3 plus 4 plus 2, yes, it is 9. Then it is definitely divisible by 9. So let's try. Okay, times 3, 27. 34 minus 27 is 7, and then 2 comes down, times 8 is 72, so 0. So this number is definitely divisible by 9. So you have to always remember all digits add up to 9. They have to. If they add up to 18, let's say we have a number which is 891. This is going to add up to 18. Then you again add up 1 plus 8, which will give you 9. So end number, single 9, you should get always single 9. If you're getting that, it is divisible by 9. Okay. Next one is again the easiest one, which is divisible by 10. Okay. So for a number to be divisible by 10, the last digit of the number should be 0, or the number should be ending with a 0. So let's say we write ending with 0. This rule pretty much everyone knows. Even a child who is in 4th grade will know this rule. That if you see 20, you know that 10 is one of the factors of 20. Okay. Next one is divisible by 11. Now this rule is slightly complicated. What this rule states that if addition, sum of the difference between the sum of odd place numbers and sum of even placed numbers is either 11 or 0, then the number is divisible by 11. So let's take a very huge number. Let's say I have a very huge number, 12,320. I will explain to you what it means. So what I'm going to do is I'm going to take 1. Okay, this is at first place. Then I'm going to take 3. Then I'm going to take 0. Okay, minus 2 plus 2. So I have 4 minus 4, which is equal to 0. So this number is definitely divisible by 11. So you have to take these digits, add them up, and then you have to take these digits, add them up, and take the difference. It doesn't matter whether you have a negative 11 or positive 11. It is still going to be, or the, if you are getting 11, it will still give you the same thing. But still we will check our hypothesis, or not hypothesis actually, we'll check our statement. So times 1 is 11, 1 comes down. Again times 1 is 11, 2 comes down. Then 2 will come here. Times 2 is 22, 0, then 0 will come here, so 0. So 11 times 1,120 is going to give me 12,320. So I know that this number is divisible by 11 because the difference between the sum of the odd place digits and the sum of the even place digits is 0. So it can be 0 or it can be 11. It doesn't matter. Okay. So let's say I have a number. Let's make up a number which will give us. So 8, 5, 7, 0. Sorry, 8470, not 857. 8470. Okay. So we have 8 plus 7 minus 4 plus 0. So it is 15 minus 4 is equal to 11. So this number has to be divisible by 11. So we'll see, we'll check. So 11, 8470. So, sorry, what did I do? I'm so sorry. See, this happens. Now what I did here happened, the careless mistake that happened just now, it happened because my brain is thinking faster than what my hands are writing. So even before I started writing, my brain was already thinking 8470. So instead of writing 8470 below the division line, I already wrote it before. So these kind of careless mistakes can be avoided if you start matching up the speed of your hand and the speed of your brain. It needs a lot of practice. So if you start early, by the time you reach the crucial years of your education, like grade 9 and grade 10 or IB1 and IB2, you will have enough practice to match the speed of your hand and your brain. It is generally easier to speed up the speed of your hand than slow down the brain. So try to speed up the way you write, or try to match the speed up your writing process. It will help you to avoid many careless mistakes that happen when your brain is working way ahead than where your hand is right now. You can this will help you in English, this is going to help you in your languages, all kind of languages, in science, in all subjects basically. So when you are writing, your hand must match your brain. Trust me, it is going to save you a lot of marks. Okay, I am going to throw in few of these tips here and there, so remember to watch the entire video. Okay, so this is 8470. So 11 times 7 is 77, because that is the smallest number before 84. So we have 7, and then this 7 comes down. So again we have a 7 over here, 77, 0, and then again a 0. So this number is also definitely divisible by 11, because the difference between the sum of odd place digits to the sum of even place digits is 11. Okay, yeah, it's a very interesting rule, but very, very useful. And the last one, that divisibility rule that you need to know, is divisible by 12. Now this rule is same as if it is divisible by 2 and 6. Okay, if any number is divisible by 2 and 6, then the number is divisible by 12. Okay, so these were the divisibility rules. If you have missed any of them, once we finish this session, you can go back and watch the video and see what you can get from there. If no, you can drop me a comment below the video, or you can always drop an email to me on this email ID, ImproMaths at gmail.com, or you can visit our page, ImproMaths on Facebook and drop me a message there. There are a lot of ways to communicate with me, so you can use any of them for any of your questions regarding the topics that we are covering, so that I can give you the explanations that you need. Many times it will so happen that I'm going at a very fast pace. You can give me a feedback also. Okay, so you are going too way fast. Can you slow down? I will definitely try to slow down. Okay, but I need a feedback from you guys that okay, you need to slow down, you can go slightly faster, no need to go into so much detail, because I like to go into details when it comes to mathematics. Mathematics is a very very interesting topic, so the more details you get, the funnier and more interesting it gets. And my aim here is for you guys to start liking mathematics, not treat it like an enemy, but treat it like a friend. According to my experience in past 10 years and when I was a student like you, if you put your 100% in mathematics, mathematics is definitely going to return back 100% to you. It is like a best friend in whom you invest. He will treat you the same way you treat him. Okay, so make sure that you start getting interested in mathematics, because that is going to save you lots and lots of pain in the next few years. The more you like mathematics, the easier your life is going to be, because that one subject is aside. Okay, I like mathematics, I can do mathematics nicely, so I don't have to worry about it. And it's my job and my role and my wish here to start this live streaming is to make you people like mathematics, not make help you people like mathematics. And trust me, mathematics is one of the most wonderful subjects in the world, and if you keep at it, there is no such thing as no mathematics brain. I don't believe in it myself. I feel and I am sure and I believe in this, that every brain, every child, every person on this earth is capable of doing mathematics, even though they have some developmental disabilities. Normal people, definitely, even those with developmental disabilities, if trained properly, can do mathematics. And surely, trust me, maybe they won't be able to do like all of you, but they will, they can do mathematics. So mathematics is one subject which has nothing to hide, or that is like in English, you write a composition, maybe you don't handle the subject properly and you lose marks over there. In mathematics, it's all fact based. You have facts, you write them down, you use the rules, you lay out the facts, and you get 100 on 100 on, for your answer. That doesn't happen in any other subject. Maybe in physics and chemistry to some extent, yes, but languages, no. History, no. No other subject does like that. Any subject that is subjective, which has lot of writing down in it, will not give you that. But maths, yes, definitely. You lay down the facts, you do everything mathematically correct, and it will ensure that you have 100 on 100 over there. So trust me, maths is really very interesting, and I'm on the mission to make it interesting for you people. Okay, so now let's use the divisibility rules that we did over here and factorize this pretty big number. Okay, so we know that it ends with a 0, so we always start with the smallest prime number. So I'm going to divide this with a 2. I hope you people have done this branch diagram before. So it is 2, and then we have 10800 divided by 2. 5 times is 10. So 8 comes down, 4 times is 8. 0 comes down, so 0. We have 5400. Now, generally, when we factorize, we don't use composite numbers. We only use prime numbers. So I could directly use 10 over here, right? Divide 2 times by 10 and I get 108. But I can't do that because I want prime factors. Again, this one. So 2 times, it's 2700. Again, 2 times. 2700 divided by 2 is 1350. Again, divide this by 2. We have 675. Now we have to stop here. Either we can use 5 or we can use for 3. So let's say 6 plus 7 is 13 plus 5 is 18. So this number is definitely divisible by 3. So we are going to do 3 times 2 to 5. Now this number is also again divisible by 3. So we are going to do 7 and 5. Now this number is again divisible by 3. We are going to get a 25. And then we are going to get our favorite little 5s. 25 is 5 times 5. So now I'll make it slightly smaller so that we can see all the numbers. So if you see, there are a lot of 2s, lot of 3s and lot of 5s in this. So we have 1, 2, 3, 4 2s. So your 10800 is going to be equal to 2 raised to 4 multiplied by 1, 2, 3, 3 cube multiplied by 5 square. So your 10800 can be factorized like this. Now if before this you had factorized 10800, you would have written it like this: 2 into 2 into 2 into 2 into 3 into 3 into 3 into 5 into 5. Oh my god, so many numbers. This is easy, right? 2 raised to power 4 into 3 cube into 5 square. So this is how we use our index forms. So I'm going to give you a pretty big number which you can factorize for me, and then we will go ahead and do square and cubic form. Okay, more details of square and cubic form. So my number here is going to be 45,000. Okay, so how about you take about 2 minutes to factorize this? Use all the divisibility rules and let me know how you will factorize this one. For ease of solving mathematics, there are few rules that you need to follow, and if you start following them now onwards, your life is going to get slightly better. First of all, make sure that you make a notebook, pretty sturdy notebook, in which you are going to write all these concepts, the divisibility rules that I'm teaching you, the formulas that we are going to learn, and you keep on adding in that book. It's like your go-to book for mathematics formulas and concepts and theories, everything. So whenever you learn a new concept of mathematics, you write it down in that book. So you will, by the time you reach your 10th grade, you will have a pretty good collection of everything. Now IGCSE papers are known to give you few formulas, which is very good. They don't want to stress your brains with formulas, but they don't give you all formulas. They only give you basic volume formulas. So all the other formulas, you are going to learn lot of formulas till IGCSE 10th grade or maybe till IB2. So it's better if you start writing these formulas down. And to take it one step further, make a practice of reading that book every day. It will hardly take you 10 to 15 minutes every day. So when you're on your way to school, or coming back from school, or you're going anywhere, or you're just about to sleep, just go through that notebook once, and then because we are going to get into a process of engraving these formulas into your brain, so that when you really need those, you don't have to scratch your brain for the formula, or forget a 3 over here, or a power over there, or a dividend over there, something like that. So what we are going to do is, we are going to use a form of repetitive memory engraving in our brain. So there is something like you keep on doing, right, again and again and again and again. It becomes a habit, and it makes connections in your brain, so that whenever you need that information is faster available to you. So we are going to use this property of our brain of making new connections and remembering things which we see, which we do repeatedly, so that when your actual time comes to write down these formulas and get acquainted with these formulas, or use those formulas actually, you don't have to waste your time in remembering them. This, in my last 10 years of experience, has proved to save about almost 30 to 35 marks here and there in all the papers. So in IGCSE grade 10, for 0580 code, you have a 200 mark paper, which is divided into 70 and 130. Just imagine, in a 130 marks paper, just because you remembered your formulas correctly, you save about 25 marks, and in your 70 marks paper you save about 10 to 15 marks. That is going to make a lot of difference in your grades. So make sure that you write down these things in a notebook, in a separate notebook. Make sure that that notebook is very sturdy, because you're going to use it a lot for next 3 to 4 years. And trust me, this is going to help you a lot, a lot. Second thing that I will suggest, and I feel that this also helps you, is make sure that you know your times tables, multiplication tables. So at least multiplication tables till 30, and then you know your squares and your cubes till 30. Cubes till 20 is still okay, but squares till 30, or if you're enthusiastic and you have started liking mathematics, you can go as above as 45 or 50. This will help you to see patterns in numbers. So whenever you are solving something and your calculator, sometimes it so happens that if you know all these things, your calculator takes more time than you to find out the answers. Okay, so let's see what we can do. So now we have to factorize 45,000. So we'll start with 2. Yeah, I know dividing by 2 is very difficult. This helps a lot. So it is 22500. Again, divide by 2. It's 11,250. Again, divide by 2. It's 5625. So 5,625. Okay. Now, just see if this is divisible by 3. 5 plus 6 is 11. 11 plus 7 is 18. So this is definitely divisible by 3. So it's 1875. You can see the number going slowly down, right? Now, is 1875 divisible by 3? Yes, it is divisible by 3. It's 9 plus 12, which is 21. So again, we are going to divide this with 3. It's 625. Now 625 is square of 25. So we know that there is no 3 or 2 or any other number in this. So I will divide by 5. I will get 125. Now 125 is cube of 5. So again I will divide by 5. See, these kind of things you can do easily when you have your numbers in order. So now I'm going to make it smaller, because it's a pretty big chain of numbers. Okay, so my 45,000 can be written as 2 into 2 into 2 into 3 into 3 into 5 into 5 into 5 into 5. So much space. So much air is wasted. Yeah, so it is 2 raised to 3 into 3 raised to 2 into 5 raised to 4. So short, sweet, and simple. So this is how 45,000 can be represented in index form. Now next one that we are going to do is we are going to do squares and cubes and understand what it exactly means. Okay, so when we say square of a number, okay, it means the number is multiplied with itself. So it is 6 times 6 is equal to 36. This one looks like area of a square. You have done area of a square in previous years, right? Now, so it is 6 square. That's why it's called a square basically. Now, we have 6 into 6 into 6, which is 216, also can be represented as. Now, this is a formula of volume of a cube. That's why it is 6 cube. Okay, so squares is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, if I 1, 2, 3, 4, 5, 6, not this one. This little dot is extra. Okay, so if I do this 1, 2, if you count, there are going to be 36 dots in this. So 6 here and 6 rows and 6 columns are going to give you 36 dots. So it is 6 square. I cannot represent it a cube in this form, but if you see, I can show you a picture if you want. Give me a moment. Okay, let's see if I can reproduce this picture over here. Okay, as I had told you last time, I'm going to use Hayes and Harris book for mathematics for grade 7, the MYP book. So if you want, you can get that book over here, or you can buy it online on any of the sites where it is available. Maybe next time I will write down the sites in the comment. Okay, so this is how a cube will be represented. If you see how many squares are there, 1, 2, 3, 4, 5, 6. Here also 2, 3, 4, 5, 6. And here also 1, 2, 3, 4, 5, 6. So this is how a cube is represented. So that's why it is a square and a cube. So 6 power 2 is 6 square. 6 power 3 is 6 cube. Okay, this is what we are going to do is we are going to stop here today, and before I go, I will give you a slight homework to do. So your homework is multiplication tables till 20. Then squares of numbers till 20. And cubes of numbers till 10. Again, I'm stressing the importance of this is you will see, I have calculator, I can always I will always calculate. But sometimes it so happens that you can't reverse engineer on a calculator. Like 45,000. How would you know the factors if you don't know any of the divisibility rules? Similarly, if you know the squares and cubes of few numbers, it helps you to find patterns when it is needed. Even the multiplication tables will help you to see patterns. See, mathematics has patterns everywhere. As long as you do the fundamentals clear, you will start seeing the patterns and you can put it into a more visible form, or it becomes easier when you see the patterns. So in order to see those patterns, you need to know a few things, and multiplication table, squares and cubes is a part of that. So we'll stop here today. That's all for today, and I will see you next week. Next week, we are going to start with angles, lines, and parallelism. Okay, parallel. Okay, it's very difficult. Basically, parallel lines. So I'll see you then. Till then, bye bye.